Hiromi,
Hi.
now start YouTube.
Okay, so please hang tight 3 or 4 minutes.
Okay.
Okay. So just 13
13.
joining.
Uh-huh.
Yeah.
Okay.
So please waiting. So, hello everyone. Good morning, good afternoon, and good evening, and welcome to the AWS Global Community Gathering. So, I know we've got folks joining from all different time zones. Thank you so much for being here. So, we'll get started in just a moment once a few more people have joined. Please hang tight. So
Mm-hmm.
we will wait just a little longer until more people have joined.
Okay, no problem.
Thank you. We want to starting 10, 10:05. Oh, JST.
Okay.
Hmm,
Mm-hmm.
it's very quiet. Oh, 16. Mhm.
Some music. Mm,
Everybody speaker join.
people join. So mhm. So someが、綺麗な Sonic. The presenter at more one people.
More one
One.
people.
Yeah.
So,
So last presenter is not
Tanika? Oh, not yet.
not yet. Yeah. Okay.
Mm-hmm. Right.
Thank you.
Okay. Oh, 70. Oh,
Mm-hmm.
good. Very nice. Oh, In Japan, nighttime is called, right?
Or
What?
so YouTube GA speed is so checks.
The checks?
Yeah. So and
Maybe on YouTube?
SNS, yeah, YouTube, no problems.
No problems. Good.
Yeah.
That's good.
Yeah. Two people now looking,
Oh,
and so X post is now YouTube URL is post now me.
you already post on
Yeah.
YouTube, on X?
Yeah.
Thank you so much.
So no problem. You welcome.
So, all right.
Okay.
Okay. This event is available via Zoom and YouTube, and it's open to anyone around the world who's interested in AWS. That's why we are using UTC for the time schedule. And I'm currently from Japan. It's evening here, and we are is everyone is joining from. So feel free to share in the chat or post on X to let us know where you are turning in from. We are we are from. Oh, Nigeria, yes. So far. Japan, yes, nice. Same. Oh, India. Oh, Adit, thank you so much. China. Nice. Kenya. Nice. Indonesia. Live in Japan now. Oh, really? Welcome, welcome. Mhm. Oh, good. India, nice. Mhm. Oh, Yuko-san. Nice, Japan. So, uh, Asia time or noon time or evening time and midnight time. So Europe noon time. Oh, I don't know. Okay, thank you. So, right. Let's get started with the opening talk. Once again, thank you so much for joining us today. And a huge thank you to all our speakers. We really appreciate you. Today, we hear a wonderful lineup of speakers who will be sharing their unique stories and perspectives from AWS technologies to career journeys and personal philosophies related to AWS. I'm excited to hear the different experience everyone brings. I hope that even one small part of today's session becomes a hint or inspiration for someone here. Also, this global connection we are building is really special. If you'd like, feel free to share your social media handles in the Zoom chat and connect it with others. So, thank you so much again. And this community is run by Yuki and myself. If you are interested in helping out with the organizing side, please let me know. I'd love to grow this. Sorry, grow. Grow this together with you. And the next. Today's schedule. Here's this timetable. We have four amazing speakers, each sharing for about 20 minutes. From Poland, we have Adam. From Nigeria, Oluwasegun. Please forgive me if I mispronouncing your name. I'm sorry. And from India, we have both Adit and Sanika. Let's give a big round of applause to all four. Wait, five of our incredible speakers. And thank you all so much. I truly appreciate it from the bottom of my heart. And this event will run for about 2 hours. And so please stay with us as long as your time allows. So, and to all of our participants, just quick reminder. So this is online and event, and you can join in us through Zoom or YouTube. Feel free to drop your questions or thoughts in the chat anytime. And if you are able to, we'd love for you to turn on your mic and say something at the end too. One more time, let's value these connections and keep building our global community. So let me briefly introduce this meetup group. We started this community with the goal of creating a truly diverse and inclusive world through learning sessions. And by connecting with people from all over the world through AWS in technology, we hope that something shared here can become a small inspiration or hint for your life. And I especially welcome first-time speakers or those who don't often get a chance to share their stories. We'll be so happy if you could make use of this community and feel at home here. And we also have a Discord channel. If you're interested, please join us. But this community is so new, and we are figuring things out as we go. But we are excited to grow together with all of you. And next, we host events every month, and I'm doing my best to keep this community active and engaged. I'd be really happy if you continue to join us in the future. And I'm always working on improving the experience, so your feedback is more than welcome. And also, we always looking for new speakers. So if you are interested, please don't hesitate to reach out to me. And I had a lot of people reach out about speaking in May, June, and July. And thank you so much. I'm still working on the schedule, so please hang tight while I get things finalized. So, and the last, but not least, thanks again. And I'd love for you to keep being a part of this community. So thank you so much. Right. That's all. Opening talk.
It started. So now.
Yes. All right.
All right. So
All right. Let's
first,
get started with main session. And Adam, are you ready?
Yeah, of course.
Okay. So, can you share
sharing.
screen?
Yeah, okay.
Yep.
Okay.
Okay.
Hello, everyone. I would like to speak today something about backups or disaster recovery with usage of AWS. This session was created for our user group in Białystok in Poland, and it was much longer than I will present it today, but I guess this will be kind of interesting. I'm on. I have a master's in electrical engineering, and I'm a long-time IT administrator, mostly working with industry, but also hospitals and marketing sectors. Uh, I was also a teacher once that teaches people with IT skills, and currently I'm SysOps or DevOps at AWS, a company that is creating fintech application provided to worldwide, and kind of helped with creating a small book about cybersecurity in Poland that helps people to understand how to set up their own Wi-Fi at home networks. So even though I started with saying that this is a session about backups, then I'm not going to kind of explain what it backup is, because I kind of believe that everybody now knows what it is or should know. But as I believe that's actually not true, but I know I will have to kind of explain that some backups are totally bad and not enough. Maybe some of you heard about ISO standards and maybe implemented some of them. But do anyone actually read that? I guess not really, because I kind of had to. And then I realized it's totally strange how it is implemented, and that ISO actually doesn't say anything about how to back up your data or how to actually keep your business going. And even though it's ISO 27017 says about security and cybersecurity, but actually all is said there that it's up to you, and you have to know what do you have and how to protect this data and how to recover them. But there's no actual information how to do that. So it's up to you and your business to explore this in details and to set up this so it will prevent your business from shutting down. So, what is actually disaster recovery plan? This is a plan that's aimed for restoring your system to the state where it's kind of operative, that will let you bring back the data that is mostly desired for your company, that is crucial for the company to keep on running. So it's maybe some kind of payroll information, some contractors details, but not really is bringing back your whole business to be back and running like nothing happened. So there is not an option for business to really operate after just bringing the DRP. So it's just probably not enough. But to just show what DRP is used for, it's for some of typical disasters that may happen or probably happen with high probability, something like human error or hardware failures on your setups, cyber attacks that keep on rising, wars that may happen within your country or within your neighborhood. This is all that can impact all the businesses within your region. So not only war that may happen in your country, but also in the region around. So this war that we are currently having in the neighborhood with Russian and Ukraine, it's actually very impactful on businesses in Poland. So, what does this problems lead to? I guess this DRP plan is actually meant for preparing for the change, not actually for bringing back everything to life, but just bringing us to the new situation and allowing this company to live in the new world after the change. So DR still gives us a lot of actual advantages. It's improved security, faster bringing back to the business to operating, even if not fully, but just a part that we would like to see as a necessary. It kind of enhances business and continuity, but not really bringing it to the total point of saying that we are stop 100% running. No, and this is also something that provides us with high availability and reducing restoration costs. This plan, and is also sometimes required by compliance regulators. So this may really help us with our business. To be honest, this photo shown here is actual train crash I was a part of. So yes, this is mine after leaving the train. And how this disaster recovery works? It has a preventive function. We have the plan that needs to be provided before the actual problem happens. So we can activate it when something really is going on, and it has a detective function. We need to modify if something is actually failing, and we need to gather the feedback. So after the disaster, we could improve our plan. So it will be faster and better next time. What can be this part of disaster recovery plans? We may use some of typical backups. It's like offsite backups. It's mostly used on its own. So we have another place we store our data on the server that's in different location. Also, we may use backup as a service. But it has kind of same limitations. But it's only provided with help of some different provider, not our own storage, but we use someone else's PCs or servers. We may use also disaster recovery as a service. It's a complete solution that is providing us with all of the before. So offsite backup as a service, just in one. But it's also online with someone else's services or servers. We may use point-in-time snapshots, but it's something we mostly keep on our own servers. Virtual DR. It's a virtual images that we create a full environment and just copy it back if something happens to our infrastructure. It's kind of close to the point in time, but I guess virtual DR would be much more, much less often than point in time. Also, backup applications, it's just alternative sites we have in case of failure. So we just switch the location to that we route traffic to. So as a small summary of DR, it's a plan, and we have to assess risk, identify what are the risks and what we need to protect. So also optimize, report, test, and perform appropriate backups. But when does the disaster recovery stop being a problem of the IT and it becomes a business problem? Mostly when something like that of the owner or happens, or a board member or cloud provider leaves our country, or maybe some political blocks or cash flow is going down. And who actually needs that? It looks like most of the business leaders says that they had large impacts, problems with operating in last 2 years. So yeah, it's actual problem for the business. And this BCP is far extending the DR needs. That's also shows how the procedures need to work in an organization to keep the business running and say just who or what and when should happen after some major problems. It's a plan that's not focusing on restoring infrastructure, but actually restoring the whole business together to keep it running after a disaster. And what should be in this, in my opinion, actually risk management, policy strategies, and something like responsibilities of specific actions for specific people in company. It may be unethical, but it may happen as this is said here. We may need to even go for bribing, as this happens. This is business. Also, there is an option for just replication, but replication isn't really a backup. It's just a process of keeping data synchronized in two places. So when we just delete data in one of the data centers, we might lose the data in the second one. So no, this is not enough. It's just providing better time access for our clients if you use it. So what do we have on AWS? First of all, we have this shared responsibility model. We need to know where we are and where AWS comes. So we know that we have to back up our data in the cloud. And AWS just keeps the infrastructure running and accessible. First of all, we have data encryptions for security protocols and for keeping the data secure with KMS, encryption in transit, at rest, and using HTTPS and TLS when communication. We have also IAM policies and SCM policies for keeping our resources limited to necessary roles and permissions provided to these roles. Also, the SCM provides a regulatory level of compliance, so it helps to just keep the hidden from those who don't need to see. Also, we have S3 as a core of all the backup systems in AWS. It's providing 9999 of certainty of accessibility to the data, and also it's automatically providing us with multi-stored location for our data within 3 in standard mode for the data within 3 different availability zones. We have super AWS backup just for providing backups as it is for many services in AWS already. And this is kind of expected to rise. I guess this will be most necessary service in a long time. AWS backup allows for global policies on organization level, so we may have 10 or 10,000 accounts and all have the same policy on them. So we know that all instances or RDS instances will be backed in the same way. And we may monitor that on organization level if all this is happening. Also, something AWS added in October or something like that. It's aggregate votes in AWS backup for regulatory purposes. We can't then delete this data or change them in these days provided. So it's crucial for some businesses. AWS also provides elastic disaster recovery. It's a disaster recovery as a service option for creating from point in time backups entire platforms just to keep system operating. And we have also snapshots within different services of their own. This comes with sometimes, like for RDS, free tier of for data. Also, this is something very important. We need to sometimes create cross-region, cross-account backups if we want to know that all our data is accessible and not deleted as they may from time to time, even with the best practices. This is something AWS is currently suggesting to use. It's even as a cloud formation template in this QR code links if you would like to check this later. I may provide this as a whole. Also, we have long-time backup for cheaper options. It's a Glacier, and this is also S3, but with longer access times for data. Also, We have data migration options for your data within your customer's data center using data sync or AWS database migration service, with also options for changing schemas in the process for this. Also, we may use AWS Outpost just to running the AWS services on your own infrastructure if you need to, if your company have requirements for this to be present. We may also use more application methods like cross-region replicas. Also use Aurora Global databases that let for better data security and better latency. Also, we have Amazon DynamoDB global tables. It's also kind of replication for this data to be present within many AWS regions. So it's not only for keeping the fast access, but also for allowing access for others. And more services that we may use is FS replication, said before, DMS, data sync, and Windows file server replication. As a last part of the AWS provided solutions is Snow Family. It's an option for mostly importing data from your places into the AWS, and this allows for a very large storage capacity when importing data. And how we may help with our testing. AWS backup add also something called like recovery testing, and this is automated tests for backups we are creating, and we may use something like this. I provided here as a small implementation. We also use this in production when we create a restoration option from AWS backup recovery testing. We also send an information to an event bridge receiver, and this triggers a step function that says if this backup was accessible using Lambda that's run by this step function. Lambda tries to connect to the ports provided, like to for SSH with running EC2. If not, if this was not accessible, then Lambda sends some information to an SNS service, and this informs our administrators that there was a problem with restoring this backup, and we may know we had some problems with actually creating this backup. This is, I guess, this is everything for this. And thanks for your time.
Thank you so much for the great talk. Thank you. It's really impressive that you've been working as an IT administrator for so many years, and data protection and management are such important topics, especially these days when we never know what might happen. Being prepared is more important than ever. So I also really appreciated learning about the situation in Poland. It gave us a lot to think about and helped us understand things better. Thank you again. So does any have any questions?
Thank you for your time.
Thank you. Thank you. Does anyone have any questions or comments for Adam? Uh, you can drop in it in the chat or just unmute and say it out loud. Totally up to you. Any question or comments?
No comment and Twitter and YouTube post no.
Mhm.
So
Oh, thank you. Yes.
yeah, thank you. So
Right. Next.
this-
Mhm. Okay. Next, all the words again. Are you ready?
Yes, I am. Yes, I am. Just here. Can you hear me
Hello.
clearly? Oh, yeah, that's good. That's good. Yeah, thank you for having me. Let me share my screen. I'll do a brief
Okay.
introduction. Please let me know if you can see my screen. Thank you.
Mm-hmm.
You can.
Oh, I
Oh,
can hear.
perfect. Nice, nice, nice. 1 second. Okay.
Mm-hmm.
So yeah, my name is uh okay, can you still see my screen, please?
Yes. Perfect.
Perfect. All right, all right. My name is
Okay.
Oluwasegun Adediba. I know you said sorry for butchering it, but you did try, right? There's some intonation because of the language, but you did try. So yeah, thumbs up. So yeah, I am a software engineer with a background in mechanical engineering, and I got into the field of software engineering, especially with AWS Cloud, a couple of years ago in 2022 to be precise. And I started because I had a break in my school year, which led me to start looking into alternatives to mechanical engineering, which is funny because I love mechanical engineering. So during my journey there, in the cloud space, I started looking into projects that could combine both my experience as a student of mechanical engineering and my experience in the cloud engineering space. So I came up with a project to solve a problem that we were facing back then in my university days and the university premises, which is what led to this particular presentation. So I gave this presentation a couple of months ago at the AWS JAWS Pancathron event. So yeah, I will just do this again. So let me go into slideshow mode. Can you still see my screen? Thumbs up if you can. Oh yeah, thank you very much, Tal. So yes, let's dig into this. Building a serverless traffic management system. I will skip this. And yes, right. This is the entrance of the university premises. I attended the University of Ibadan in Oyo State, Nigeria. Now, if you look on the right of the image, I apologize if it is not very clear, but if you look on the right of the image, you'll see vehicles going into the school gate, right? So what happens when vehicles drive into the school gate is simple. They get inside the school gate, security men on the other side of the gate stop them. They take their vehicle details, which include the plate number and the car brand, and now they do this manually. So the problem with this was that in rush hours, like for example, a Monday morning, everybody's trying to get into the school. So in rush hours like that, when you manually take people's car details, their plate numbers, and their vehicle logos, it's going to cause some traffic jam. And that is exactly what used to happen. There used to be a very serious gridlock at the entrance of the gates whenever you got in. So this was what led me to trying to come up with a solution that could help automate this process. Now, yeah, so the manual registration of the vehicles led to gridlock, time wasting. And what happened after that was after each day, they just keep a notebook and then they move on to another notebook. And the problem with this, as we all know, is that paper is not something that can last forever. If I say forever, it means it can be destroyed. There could be some accident, maybe water or something that causes you to lose all of the records that you have kept. And it is going to be very hard to query data or to note or to get data quickly, because you would have to manually count and all of that, and it would be a lot of stress if you had to do that manually. So to build something like this for a university premises, which gets busy on some days and on some other days not so busy, I had to consider a couple of things. One of them was the scalability. We would want a solution that can address a number of cars coming into the school on a particular day. For example, it could be a convocation ceremony. If it's a convocation ceremony, we're going to have a number of vehicles coming into the school premises, right? So there will be a number of people coming in, and not only will it wear the people manually taking the information, if this is done on a system that cannot handle such scale, it will crash. And it was something I considered. We wanted something that could process images in real time or as close to real time as possible. We considered the security of the individuals bringing their vehicles into the school premises, because we're collecting critical information like the plate number. And then we wanted to store this data as well. So we wanted a solution whereby you can save data for days, and then you can go back and you can query for up to 9 months, 10 months ago, and then you can analyze the number of vehicles that have come into the school premises for a particular month, a group of months, or a year, and so on. Now, the initial architecture for this solution was simple. Like I said, I have an experience in mechanical engineering, so I tried to bring in some IoT into this. There was going to be, in the place of the actual gates, the initial design was a boom barrier, right? So this boom barrier is going to be controlled by a servo motor. I'm not going to bore us with some of these things. I'm not sure everyone here is familiar with IoT terms, but it's controlled with a servo motor, which is responsible for opening and closing, basically. So that would be controlled by a microprocessor, which is an Arduino Uno. And then the way it would work is, when a vehicle approaches the gates, an entire process is triggered by a sensor very close to the gates to take a picture of the vehicle coming. So the vehicle is coming this way. There's a camera, and it takes a picture, it sends it via IoT code to a Lambda function to S3 buckets and all of that. I'm going to skip explaining this for a reason. Now, the reason was, in the course of testing, I realized that we would need pretty clear images to be able to implement this solution properly. Now, the problem with AWS IoT Core, as at the time this was done, was that it couldn't accept past a particular size of images, right? So if it was larger, I think the limit was, I don't remember correctly because this was done. There was a limit, and to be able to accurately depict or get pictures of clear plate numbers, you would need larger images, and I think the limit was 1024 KB. Anyway, that was the problem, and that was what led to the solution that was finally used. Now, to be able to work around the AWS IoT Core image limits, I decided to use an API gateway. This way, there was no limit, but there was a reasonable limit to how much size of data I could transfer per image. And this was good enough for me to be able to proceed, because I think on the largest image size I had in the test process was maybe 4 MB. And that's not a lot if you think about it. So with API Gateway, I was able to do that. So now the implementation of this is an ultrasonic sensor detects an oncoming vehicle coming. When it gets close enough, it triggers the camera to take a picture. Now, this architecture is purely event-driven. So when the sensor kicks off the process, the camera takes an image. When it takes an image, it is configured to upload that image to an S3 bucket via the API gateway. Now, from the S3 buckets, Event Bridge rules allow us to be able to trigger other processes via events. Now, in this case, the event that was used was put bucket for any image extension, which is JPEG, PNG, whatever. So now when an image is uploaded from the camera, it goes into the S3 bucket. When it goes into the S3 bucket, the Lambda function is called. Now beforehand, I trained a model. I'll show it at some point in this presentation, or let me just move. Yeah. So I trained this model to be able to detect car logos using AWS recognition. I used AWS recognition for one reason, the learning curve, right? It's as simple as using an API. So you do not have to have an extensive knowledge of data or machine learning. You can just use this, upload the images you want to you use to train your model and train, and it's that simple. So I used 2,400 images to train the data set to recognize 8 specific vehicle brands, which are very common in this place in Nigeria. And I had pretty decent evaluation results because an F1 score of 0.94, average precision of 0.96, and an overall recall of 0.93. So these are pretty good metrics for it. And these are some of the results I got using these plate numbers. Now, these plate numbers here are personal ones, which is why I can share, but I just wanted to show proof. Okay, so let's go back to the architecture now. So when the image is uploaded to the S3 bucket, Amazon recognition does two things. It detects the vehicle logo, which tells us the brand, and then the plate number. There is an API for detecting texts and pictures with Amazon recognition. So there were two APIs used here, one for the train model and one for the text. Now, when this is done, whatever you get is stored in DynamoDB. I use DynamoDB because of the scalability of the database, and the fact that we can export data as we want as a CSV file for a particular range or some query or whatever it is that you have. Because we used it DynamoDB, we were able to also link Amazon SNS. Now, Amazon SNS is simple for the notification system for those that aren't familiar. So with Amazon SNS, I could send an email notification that I showed. I could send a text message, and I could also send a response back to the Arduino or the microcontroller's IP address, which will trigger the closing of the gate. So all of this happens in less than 2 seconds, this entire process, from the process of a vehicle approaching, the gate being triggered to open, and the process of it being recognized or being detected, and then the notification from SNS also tells the gate to close back. So it's an entire loop, which is all event driven and kicks off by the detection of a vehicle coming into the school. So yeah, I just wanted to point out this. This is the SNS text messages I connected to my phone, all of that. This is DynamoDB. Now, this helped us to solve that particular problem, but unfortunately, it did not scale because there was no funding to do this on a large scale for the university premises. So it just ended up as a personal project, which is still sad because I tried my best to push it. But yeah, in a place like this, there are a lot of things involved. But I was able to pick a problem around me and do something about it. And I think that will be my charge to every one of us today. We have unique problems in our environments. And as agents of change, I believe that wherever we are, we can enforce change. We can enforce positive change using our skills. And it doesn't have to be something grand. It doesn't have to be something that people would not think of. It could be something as easy as ensuring that you do not have traffic gridlocks. So yeah, this is my charge to every one of us today. Just pick a problem around you and do something about it. Yep. This is my name. We can connect on LinkedIn, on Twitter. My email address is here. Yep. So thank you very much. You can also connect with me. You can you can check my blog posts if you're interested in reading. I have a couple of things I write about security. I have a background in DevOps as well, so you find some of those. If you love Terraform, I love Terraform too, so we automatically friends and all of that. But yes, thank you very much for having me.
Thank you. Thank you so
You.
much for sharing your amazing story. I
Thank
think
you.
you I thank you so much. I think your background and work you are doing are really inspiring. It gave me a fresh perspective, and I personally love simple serverless architectures. So hearing about that made me really happy. So
Nice.
uh, nice serverless, I love it. So it's a great fit for solving real problems, and it clearly shows the probabilities that are out there are really impressive. Thank you so
Mm,
much.
thank you.
And thank you. And then, does anyone have any comments or questions for or this game? Or feel free to share in the chat or unmute yourself and jump in. Do you have comments or question?
So I think okay. I think so. I created IoT notify. So very nice idea. It's nice slide. I
Yeah.
think. Thank you.
Oh, thank you very much.
Thank you.
So,
Excuse
and
me?
YouTube
Oh,
and YouTube
Go
and
ahead.
X not comment. Mhm.
But
I have a question.
yeah,
Yeah,
thank
sure.
you.
Okay.
Hi.
I'm not good at IoT. So, uh, is this structure near real time? How long does this entire process take?
Oh yeah, it takes less than 2 seconds for the entire
2 seconds.
process, but it is heavily dependent on internet speed too. Because I mean, yeah, you're transferring to S3 and then you're communicating back to your microcontroller. So if there is some latency due to the internet speed, then it will be longer than that. But we tested once, and taking the time it takes a vehicle to actually go, the lowest time that we had was sub 1 second. It was lower than 1 second. So it
1 second.
the vehicle approach, it captured it and it just opened and it went. It was that easy. So it's a but on an average, just less than 2 seconds, slightly.
Thank you.
Yeah. You're
Yeah,
welcome.
very
Thank you,
cool.
Naka.
Yeah.
Yeah.
All right. Do you have a question or comments? Nothing? No more question? Okay, all right.
Nothing,
So, okay. So Adit, are you ready?
Yeah. Hi. I'm
Hi,
ready.
thank
I'll just
thank
share my
you.
screen.
Yes.
Do let me know when the screen's visible.
Okay, perfect.
Okay. You can see the screen, right?
Okay, here we go.
Okay, cool. Yeah. So, hi, everyone. First of all, thank you, Hiromi and Yuki, for this wonderful meetup group. Right, it's a wonderful place for newcomers as well as experienced people to speak and talk about topics which are not really represented that much. So it's a good place for everyone to come together, and it's something global, right? So people from across regions can connect with each other and share their ideas or share their knowledge, right? So it's a great initiative that you both are taking, and thank you so much for doing it. And hopefully a lot of people join in. So yeah, thanks for that. And now coming to what I'm going to present today. So my session today is mastering AWS cost optimization, practical strategies for developers and engineers. So what I mean by this topic is it is going to be around uh, AWS cost optimization and how what are the different strategies that developers or engineers should be aware about when it comes to cost optimization in AWS. So AWS is used a lot by a lot of people, but one of the areas that is neglected is cost. So hopefully during this session or after the session, my goal is that you walk away with a few key insights or few key strategies that you can apply to your AWS environments, and get to understand how possibly you can reduce cost in your AWS workloads. So that would be my goal for you all, and hopefully we'll be able to during the session have more clarity or more understanding of how you can basically save upon AWS cost, right? So the session, I'll be presenting the session. So I'll just give you a brief about myself. So I'm Adit Modi. I'm a solution architect at Lauren. Lawrence and AWS advanced tier partner. So I work with a AWS partner company. I'm also 12x AWS certified. So I've got all the active AWS certifications. So I do have a golden jacket as well. And I also am part of a few of the AWS communities and user groups, as well as community builders program. So that's about myself. Yeah, I'll jump onto the next slide, or just begin with the session. So first, question to everyone, right? How many of you have faced challenges when it comes to AWS cost, right? A lot of us, right? We all faced some other challenge when it comes to AWS cost, right? Be it something that we've spun up has gone wrong, or sometimes we aren't sure that what is actually running on our AWS accounts. And one fine day when we try and just take a look at our AWS account, we are shocked, right? Because the cost has gone very high and we weren't aware, right? So a lot of us have faced these challenges, right? And do let me know your problems or challenges that you have faced when it comes to cost. Happy to listen and happy to hear all of your challenges. And how many of you have actively looked at cost optimization strategies? So how many of you have understood that there is a problem when it comes to cost in your AWS accounts, and there are few areas or few strategies that you can apply to optimize your cost? How many of you have done it? Yeah, few people might have actually done it, right? There are few people who know about cost optimization and have few strategies that they've implemented. So yeah, I also would be happy to learn if there are some unique strategies or unique ideas that you have tried out, right? So do share those as well. Yeah, in the comment section you can share, right? Yeah, so the agenda for the session is going to be really an introduction, or an overview of the different cost optimization, or in general different optimization areas that are available for any organization that wants to do a cost optimization, right? Then we will walk onto the different strategies when it comes to cost optimization. I have divided the strategies into key 5 areas, so we'll go over and discuss on them. Once we've discussed those 5 key cost optimization strategies, then we will look into some practical tips and tricks. This is something that I feel is really important for a lot of us to practically understand what are the few things like that might not be known, right? Because it's in theory, there are a lot of things that we feel are important, but when it comes to practically implementing, there are few more important things to understand, right? So that's the third thing, and we will conclude. And I'll share some takeaways for you. So that is something that you can take away with you, and hopefully it will help you moving forward as well, right? So firstly, there is a good statement or something that Dr. Werner Vogels, who is a VP and CTO at Amazon.com, mentioned. It is cost is a non-functional requirement, which essentially means that generally, like performance, like scalability, like security, cost is never considered to be a critical component. So that is true, right? You never consider cost to be a critical component, but you should always consider as a non-functional requirement. So whenever you are creating a list of your non-functional requirements, so cost should be taken into consideration in that, because any architecture decision, any choices that you make, cost will heavily impact those choices. So something on a lighter note, on a fun side, right? We generally see these kind of memes come up every now and then, right? How did people end up losing a lot of money because they might have spun on some EC2 instance and then forgot to turn it off, right? So do be careful when you come to AWS, and when creating EC2 instances, to try and see that you're keeping those on as long as you want, unless you want to run into issues. So as I mentioned at the beginning, we'll just understand what an optimization journey for any organization or any individual looks like, right? So when it comes to optimization journey, there are four key components to look into, right? One of the first components is collaborative ownership, right? What collaborative ownership means is essentially there are a lot of teams when it comes to an organization. There could be a team for finance, there could be a team for technology, there could be a team for say something else. So a lot of teams are involved, and when it comes to optimization that you want to do, you will have to collaboratively take ownership as well as work with cross functional teams to ensure that you work towards an optimization journey. You work towards optimizing some of the resources or some of the workloads, right? So that's the first point. Second point is cost optimization. So whenever there's an optimization journey that you come across, this journey is incomplete without cost optimization. So cost optimization has to be considered uh, as one of the key important aspects when it comes to an optimization journey, right? Uh, so third aspect is visibility and transparency. So whenever you try and optimize cost or optimize uh, for any workloads within an organization, you need to have visibility into that organization's workloads. Or if you're an individual, visibility into your AWS account. And transparency. Transparency means that any individual needs to have transparency when it comes to whatever is being deployed, whatever is going on in their AWS account, right? So that is very important to have visibility and transparency. And the fourth point is data-driven decision making. It essentially means that you make decisions based on the data that you have, right? So whenever you have an AWS account, you look at some interesting metrics, some interesting data points, and based on those data points, you need to make a decision, right? So all of these four points, like collaborative ownership, cost optimization, visibility and transparency, and data-driven decision making, are important when it comes to an optimization journey for an organization. Each organization needs to have all of these 4 points checked off or ticked off when it comes to starting their journey of optimization, right? The next point that I wanted to discuss was around cost optimization strategies, right? So there are 5 key strategies that I think any organization or any individual should be aware about or should know about. Those are commitments, elasticity, efficiency, modernization, and cost-aware culture. So these 5 key strategies will help any organization take better decisions when it comes to how do you do cost optimization for your workforce, right? So I'll quickly run through each of the strategy. I'll talk about those. So the first strategy that we have to discuss on is commitment, right? Now, commitment essentially means committing to any cloud provider, be it AWS or be it anyone else, that I'll be committing to use a particular application or particular resource, right? So I'll be committing to use, say, an EC2 instance for a particular period, let's say 1 year or 3 years. And during that period, I'll probably be using that EC2 instance, right? So that's a commitment that you are giving to AWS. Now, within that commitment, there are two options that comes, right? One of the options is you can use a reserved instance. Now, reserved instance also has two options. One is a convertible RIs and one is a standard RIs, right? Now, a standard RI means that you're saying to AWS that, hey, I'll be using a normal EC2 or any resource for a particular period in time, let's say 3 years or 1 year. A convertible RI, on the other hand, means that you are flexible. So during an initial time, I may say that, hey, I'll be using an EC2 of, say, T series, but later on, I might want to switch to another series. So, or another family of EC2 instance. So that is possible with convertible RIs. Okay. Now, so essentially the RIs basically means, or reserved instances basically means that you are reserving your EC2 instances on a particular family or a particular size. Okay. The other option on the other hand is savings plan. Now, savings plan also has two options. Savings plan essentially means that you are very flexible when it comes to savings that you are doing or reserving the instances, right? One of them is compute saving plan. Here, essentially, you mean that it could be an EC2 instance that I want to save, or it could be a Lambda function that I want to save, or it could be some other resource, right, that you would like to save. It could be something around Elastic Cache or something else, right? So there are a lot of resources when it comes to reserving them, right? So computing saving plan would essentially mean other resources apart from EC2. And EC2 instance saving plan essentially means that you're saving on EC2 instances. Now, the only key takeaway from using a savings plan versus a RIs is saving plans gives you the flexibility of reserving the instance on a particular instance type. Right? So you are very flexible when it comes to using a savings plan. So whereas within a reserved instance, you have to use an EC2 instance, right? So that is the key difference here. Reserved instances, you will have to use an EC2 instance, whereas when it comes to a savings plan, you are very flexible. You could use, let's say, for now I'm using within the saving plan, I'm using an EC2, but later on I can use another resource. Maybe it's an Elastic, maybe it's something else, right? It can also be a database, right? So those kind of decisions or choices can be done, right? So yeah, that's about commitments. The next topic is elasticity. Now, elasticity essentially means scheduling and auto scaling, right? So when it comes to elasticity, it is important to note that whenever your application has workload which is very high, then you need more EC2 instances. But whenever the workload is, not at its peak, right? Its traffic is low. You might need less EC2 instances or less instances in general, right? So scheduling or auto scaling ensures that you meet your demand, be it a high demand or a low demand, and you also don't have resources which are ideal. So let's say you spin up 5 EC2 instances, but you actually don't need 5 EC2 instances. You only need one. So when you do an auto scaling group for EC2 instances, you are essentially ensuring that only the resources that are needed are going to be utilized, right? So I just need 2 EC2 instances. So I'll spin up an auto scaling group with the minimum capacity to be 1 and maximum to be 2. So in that case, if the workload is high, 2 EC2 instances are sufficient. If it is less, then it will spin down to a 1 EC2 instance. Right? So this is how you ensure that you take care of utilizing the resource to its maximum and not wasting that resource. So I mentioned maximizing resource utilization as well as reducing cost. Second point I mentioned is you understand that workload pattern. Based on that workload pattern, you adjust your scaling. And the third point is you do a continuous monitoring, and based on the monitoring, you understand the need of the resource, be it a high or a low demand, and you adjust based on that, right? So that is the second point we have. So again, reiterating, first we discussed on commitments, second we discussed on elasticity. The third is efficiency. Now, how do you ensure your application or workload is efficient? So first, one of the first things you do is you delete ideal or underutilized resources. So there are a lot of resources in your AWS account that might not be getting used. So it is better to remove those unutilized or unused resources to save up on cost. The second thing is you can do an S3/ECR lifecycle management. Now, an S3, so S3 is a simple object storage or essentially an object storage. Now, here you might use it to store a lot of data. Right now, it might so happen that some of the data that you use to store in S3 might not be actually being used. So it becomes redundant, right? Now, to avoid it being unused and staying in your AWS account, you would implement a lifecycle policy. And this lifecycle policy will ensure that if the data is older than say 1 year or maybe say 3 years, then it will automatically delete this data using that lifecycle rules, right? So this is very crucial because you have large amount of data that you may store in S3, and over the period of time, you might not remember, and it can go on to become GBs and TBs, right? So in that case, it is really helpful to have some lifecycle policies, right? And this is for both S3 as well as ECR. So ECR is an Elastic Container Registry. Elastic Container Registry contains your images for your container workloads. So here as well, I use containers every day. So there will be a lots of images that come into the ECR repository. So you should always have a life cycle on how many images you will store. It could be 7, it could be 10. That is also a very good policy to have. The third point is right sizing. So essentially, right sizing also means that there is volumes that you have, right? So if you have to store data in a S3 bucket, it would be object storage. But if you want to store, let's say, block level data, then it could be in a elastic block storage, which is EBS. So your EC2 instances would have data in your EBS volumes. Now, this data can also be optimized, and unused data in this can also be removed using a lifecycle policy. So that also is possible. So we discussed on efficiency and three areas where you can make your workloads or applications efficient. One is delete idle or underutilized resource. Two is having a lifecycle management. And three is right sizing your workloads. Okay. The fourth point that I wanted to discuss is modernization. Here, modernization means that you might want to upgrade your instance type from a older version to a newer version. It could be from a T3 to T4 or M series 5 to M6, M7. Right? So a lot of these instant upgrades give you performance advantage as well as cost advantage. Okay. The second modernization technique would be an EBS generation. So EBS volumes, as I discussed, are block storage. Generally, when you create a EC2 instance, it will use a GP2 as a EBS volume. GP2 is nothing but a version, right? So it will use that. It's an older version. To upgrade to GP3, it will give you a better performance and better cost efficiency. So that is the second point in modernization. First is instant upgrade. Second is EBS upgrade. And the third point is using a Graviton instance type, right? So generally, when it comes to an application or a workload, there are two different choices. One is using a traditional x86 architecture, and the second option is to use an ARM-based Graviton instances. Now, we're not going to much depth of the actual differences between the two, but for simplicity purposes, using a Graviton instance type can actually save you on cost, right? Because it's environment friendly as well as it is using uh, a lot of using an ARM-based architecture in the backend, which save up in the cost. Okay. So yeah, just reiterating the four things that we've discussed so far. First was around commitments, second was around elasticity, third was around efficiency, and fourth was around modernization. Okay. The last topic is cost aware culture. So for any application or workload, you need to be cost aware. There are three areas that you can explore for being cost aware. One is you can explore spot instances. Second is you can explore using serverless approach when it comes to applications. And third is you can implement some right sizing, some tagging strategies. Okay. So what does spot instances mean? Spot instances essentially means that AWS gives us some instances at a reduced size or reduced rate. So the pricing comparison of a normal EC2 versus a EC2 on a spot capacity is drastic. So it is very less cost when it comes to using a spot instance. The only downside is it will be made available to you for a 1 hour only. So for that particular time period, you can say that I want to spin up a spot instance. After that period is over, it can go again back into the pool. So that is the only drawback to using a spot instance. But generally, a lot of the non-production workloads, which is your development and testing, uses a spot instances. So highly recommend you check spot instances out. It could be really helpful for your workloads. Second is using a serverless approach. So whenever it comes to applications, there are which are managed without servers, you generally try and use a serverless approach there. So you don't need to manage the servers and run into an additional cost. Uh, I think in the previous session also, you saw the event-driven architecture. That also is very helpful because there you are not spinning up servers and essentially you are reducing your cost when it comes to running applications in a serverless approach. The last topic, the last pointer in the cost-aware culture is right sizing and tagging. So can ensure that you right size your resources as well as you tag your resources. So you are aware that this resource is for this particular environment, this resource is for this particular project. So essentially, this will help you when it comes to checking your AWS cost and checking for which environment is costing you how much and which project is costing you how much. Okay. So yeah, we discussed on the five important things: commitment, elasticity, efficiency, modernization, and the last thing was about cost-aware culture. Now, the final topic that I want to leave you with is practical tips. So what I have observed generally is you should always have regular cost reviews. So once a month, there should always be a cost review and an audit wherein you just check your monthly cost bill and try and understand the reasoning behind that bill, whether that bill is fair, what are the resources that you are using in that particular month, and you can understand more about it. Okay. So the first thing you should do is you should do a cost review. Second thing that you should do is you should set up alerts for unexpected cost. So there is something called AWS budgets. Do check that out. Essentially what you're doing is you're saying that, hey, if my cost goes above say $10, please alert me. So whenever there is a spike in your cost, you get immediate alerts. It could be via email, via SMS. Third thing is budget policies. So you should always have policies for uh, cost going above certain limits. One of the options was AWS budgets. Another thing is anomaly detection. So essentially what you could do is you could say that if you detect any anomaly, if you detect that a particular AWS service is costing you more than it should actually cost, then you should alert me. So that is also possible. Okay. So that is the third option, budgeting policies. Fourth option, I think we already discussed on right sizing and EC2 instance management. And then the fifth option is using a spot and a reserved instance types. So I think that should be, 4 or 5 tips for you. I think that will really help you in the long term when it comes to saving up cost for your workloads or for your environments. This 4 or 5 policies, 4 or 5 areas will really help you. The conclusion or the key takeaways for you from this session would be first, if you are an organization or people who are working towards any project where you are using AWS workloads a lot, then do collaborate across teams. There might be teams who are siloed, so they might be working independently. They might not be aware that there is a cost that is going up. So collaborate across teams and try and identify areas for cost optimization. Two, right size your resources. So it is essential to understand if a resource is being underutilized and right size it so that it is used to an optimal capacity. Three is implement tagging and cost allocation. So tagging is really important to understand which resource is of which environment and for which project, because it will eventually help you with a overall understanding of your cost around each project and around each environment. And the last point is continuously optimize. Mostly when I work with organizations, I've noticed that it becomes one of the important thing that I've noticed is people generally do cost optimization as a one-time activity. They don't consider it to be a continuous activity. So always ensure that you continuously do optimization for your cost and for your AWS workloads. Uh, do reviews frequently and do try and ensure that cost is considered as a key requirement when it comes to your applications or your workloads. If you have any questions or need to ask something, then hopefully we can discuss on that. Yeah, thank you for having me. These are my socials, so you can connect on with me on LinkedIn or with on Twitter as well.
Thank you. Thank you so much for sharing such a really, really, really important topic. Cost is always a through one. It's something everyone has to face, whether as an individual or a business. What we value can be different for each of us, and that's okay. And but it's so important to think about these things collaboratively across teams and departments, even if it takes time and resources. It's definitely worth it. And thanks again for bringing up such a meaningful discussion. So, got any comments or question for Edith? And feel free to throw them in the chat or just unmute and jump in. Nothing? Nothing more?
Hello, can I stop a little bit? My name is Tao. It's beside of the topic we are talking, but I just wondering, like curiously, like how did you how to pass the AWS certification? Like I'm trying to qualify the certificate, but it's take me a lot of time. Because of course, like your lecture like really impressed. Like I learned a lot from the course optimization, but yeah, just wondering how to pass the exam in the short way, you know.
Yeah, I think I do get it. Like I do get asked a lot about the certifications and exams, because it is hard to see people getting certifications and then even 12 certifications. But for me, it is a continuous process. I get enjoyment and I get joy when I study for an exam, and I spend time learning about new stuff that I wasn't aware about. And hopefully my recommendation to you would be don't treat the certification as an exam. Treat it more as a journey, or as something where you learn new things that you might not be aware about in the AWS ecosystem, the resources and the things around AWS. Treat it in a way that today you get to learn something new, tomorrow you get to learn something new, and throughout that process of learning something new, you qualify, or also tick off some boxes so that you can get a certification towards that as well, right? But yeah, treat it as a part of your learning journey, because this will eventually the certification will also help you, and this learning will also help you with in your industry, or in your actual when you are deploying things, when you're working on projects, when you're working on real world applications. This learning will really help you, right?
Oh, thank you. That's wonderful. Like, yeah, I got like confused like a little bit. Like, should I learn more or training more on the exam and then go to the industry, like maybe like a AWS or maybe like a cloud job or something like that. Yeah, but I think I get the point that you're saying, like, just learning and the new thing and take it on the, training and your hobby. I think so.
Yes,
Yeah,
yes.
thank you.
Thank you.
Awesome. Awesome sharing. Thank you. So, all right. Our final speaker for today is Sanika. Are you ready?
Yeah, I'm ready. So, am I audible? I hope I'm audible.
Mm-hmm.
Yeah, just allow me to share my screen. Also, my topic very much resonates with what Adit said about like FinOps and cloud cost optimization. So, yeah, it's better that like he gave pretty much insights into that so that I can like be able to explain it more clearly, and like everybody must be having a better idea than for now. So
Mm-hmm.
basically, the topic that I'm going to present today is about the art of writing no cost code in AWS.
Sanika,
So, yeah,
can you hear me?
yeah, I can
So,
hear you.
your screen on it's not speaker mode.
Just give me a second. I'll just do it.
Thank you. Oh, great. Perfect. Thank you so much. Oh, on
Yeah,
mute.
yeah.
Okay.
Sorry for the yeah. So I'll just start. So the topic that I'll be presenting today is about the art of writing no cost code in AWS. So basically this topic is like aiming for again like developers and people who are into cloud and who are dealing with cloud cost. And of course, like even when you are in software and in your IT industry, writing code is what everyone basically does in their day-to-day life. So along with the code, you along get piled up with a lot of cost. So today I'd be focusing on what you can take, like what measures you can take so that you could get rid of those costs. So this basically is for creating code that is efficient, easy to maintain, and whether it's time, money, or computing. So let's see those strategies. So basically, like first, I would start with my introduction. So I'm Sanika Kodgire. I'm currently working as a software engineer at Hewlett Packard Enterprises. So I'm currently up with my first job. I'm also in my last year of my university as well. I recently got selected as an AWS community builder, and I am also an author of the book that is titled as Soaring Brimstone's Flight. I have also done certifications in AWS, Google Cloud, and Azure. I'm a public speaker and I am also a technical writer. So basically, when it comes to technical writing, my area is FinOps. So let's get started with today. So basically, introduction to AWS and cost management, and Adit like covered most of it, and it gave us like pretty much insights. So basically, AWS, like the overview is like AWS is about provides cloud computing services, including storage and databases. There's one thing called as AWS free trial, which is a limit to how much resources you can consume without paying for it, and the importance of cost management. Like whenever you are using or utilizing AWS services, you should be having a proper cloud cost so as you avoid unexpected charges in the cloud, and automatic scaling and cost of monitoring tools. So basically we would like see more about as we go ahead. Yeah. So free tier like basically the free tier. So as I mentioned, like the free tier is all that you have a limit to, and you can use these resources without paying for it. So these are basically few of the services with which I have created the serverless application, and the limit for EC2, Lambda, S3, RDS, and DynamoDB have been outlined. So if you are using EC2 for 750 hours per month and the instance is T2.micro or T3.micro instances, you won't be get billed at all. So you can build whatever you want if you are, lying in this span of usage. Then also for Lambda, you have 1 million requests per month as a free tier. And for S3, it is like 5 GB standard storage and 20,000 get request. For RDS, it's like 750 hours per month for db.t2.micro instances. And DynamoDB, you have like 25 GB of storage and 25 provision write capacity. So basically, why is writing like cost effective code important? So basically, like when you're dealing with high cost, even if you perform like basic strategies, like even if you just avoid over provisioning, like for example, if you are working on EC2 instances, and if according to the metrics you have your CPU utilization, read write throughput, latency, volume, and all of those things, and if you monitor them, and based on their usage you just see that the instance class that I've selected for my particular instance is not right, like it's above the limit, so we can just downscale it. So if you just downscale it, you are going to save a lot of cost. So basically avoiding over provisioning is also leading to help you save a lot of cost down the lane, and again minimize resources. Like as I mentioned that this topic is specific to writing cost effective code, and we would be specifically like focusing on Lambda. So when you want to minimize resources, you should be using like serverless services like AWS Lambda, that is going to help you reduce your infrastructure cost. So let's see about optimizing storage, S3 and DynamoDB. So whenever like you're building your like serverless architecture, you should be also be dealing with storage costs that come along the way. So whenever you're dealing with S3 or DynamoDB, so the main reason where S3 is like S3 charges with a lot of hidden storages. So the main thing for optimizing S3 cost is like implementing lifecycle policies, utilizing intelligent tirings, like choosing a proper storage tier. So those are the basic strategies that you can have for implementing S3 in a cost effective way. And then again, S3 is for storing static files, automatically moving data to Glacier or delete old data to save cost. And also the free tier limit is like 5 GB of storage with 20,000 get request. So, and when it comes to DynamoDB, you have predictable workloads to avoid provision throughput charges, and you also get 25 GB of storage and 25 read-write capacity units. Next. Yeah, so basically you must have seen this thing about S3, and as I highlighted about using S3 lifecycle policies. So like whenever you have your spiraling S3 cost, then S3 lifecycle policies are the only, not only, but they can be considered as a rescue. So if you just want to stop your storage cost, so just try S3 lifecycle policies, and you would be definitely be able to see a lot of changes and escalations in your cost. So that is going to make a huge difference. So S3 lifecycle policies is one such strategy that you should be implementing for your storage cost. Next is introduction to serverless architecture. So basically, what is serverless architecture? So serverless architecture, like everybody is hearing this in like today's time. So it's a modern approach to building and deploying applications without worrying about managing servers. And instead of provisioning, scaling, and maintaining servers, it helps you to focus on writing code in the cloud and explore how serverless architecture work the benefits they offer in terms of cost efficiency and scalability. So serverless architecture is just helping you to write cost efficient code in the cloud. And the main benefits or the main reasons why people switch to serverless is because it helps you to have no infrastructure management. It leads you to automatic scaling, like serverless platforms scale up and down dynamically based on the demand. It is resulting into cost savings, so that is for helping you to pay for the actual execution time instead of pre-dedicated resources. Also, this serverless application was leading you for a faster development and a deployment. Like it focuses on code rather than infrastructure. So it's also speeding up your deployment, and it also comes along with fault tolerance. So this is why like serverless is much more preferred. It's faster, it's efficient, it's scalable, and it is of course better than other models, like because it features traditional servers, scalability, auto scaling, and all of that. So basically, this is why serverless architecture is much more preferred, and serverless architectures is also like helping you to reduce your lambda cost. So lambda is basically a function that is used to trigger your code. It's a service in AWS that is used for like deploying your code and testing it. So serverless architecture is going to directly help you to reduce your lambda cost. Next. Yeah. So again, this is also very funny meme. Like for example, if you're having a skyrocketing AWS bill, and if you are implementing serverless architecture, so you're just skyrocketing bill is just going to shoo away. So just try implementing that architecture, and again, just like S3 lifecycle policies, you are going to see a much more huge comparison in your bill and the differences in the pricing. So yes, as the topic is about writing no cost code, so firstly we would like just dive into the 7 best ways to reduce lambda cost. So basically, first is right sizing lambda resources. So as I mentioned, like right sizing and like using resources that you need according to your business needs is very much crucial. Like you should adjust memory and CPU allocation so that over provisioning, so that you don't over provision your resources and reduce unnecessary cost. Next, you can also use Amazon Code Guru Profiler. So basically, what is Amazon Code Guru Profiler? So Amazon Code Guru Profiler is basically a service that is helping you to identify and optimize inefficient code to reduce time and execution cost. Next, we would see other 3 strategies. So enable AWS X-ray. So Amazon X-ray is a powerful service that is helping you to analyze and debug applications in real time. So it's especially useful for serverless applications where multiple AWS services might interact in complex ways. So like enabling X-ray allows you to trace requests as they flow through your application, providing you with valuable insights and performance bottlenecks. And when you enable X-ray, it captures the path of request and how they interact with different resources. And like Lambda functions, API gateway, DynamoDB, and others also help you to visualize your performance and application. So with AWS X-ray, you get to segment every aspect of your application, and eventually it is helping you to reduce your cost. Next, migrate to Amazon Graviton 2. So basically, Graviton 2 are instances which are helping you to reduce cost along with better provisioning and functioning. So switching to ARM based Lambda functions for lower cost, high performance computing is also a great strategy, and that is helping you to reduce your Lambda cost. And Graviton 2 processors offer like improved performance across various workloads. So particularly in like if you see compute extensive tasks, they provide like nearly 40% better price performance than your previous generation, that is like Graviton 1, which are ideal for your application, and they also like provide you with fast and efficient execution. So when we also talk about Graviton 2, they are like energy efficient. That means like they deliver more processors, and the performance per watt is also, much more better than your traditional processors. So this is also, helping you reduce your carbon footprint, and then again maintaining high performance applications, which is also helping you to reduce your cost. So migration to AWS Graviton 2 is also an important strategy. Next, leverage compute plans. So also like when Adit like in his presentation mentioned about compute plans, that is like reserved instances and compute plans. So this is also one of the savings opportunities or the savings enablements you get into AWS. So AWS offers compute saving plans, which are like flexible pricing that can help you to reduce cost on AWS Lambda workloads. So when you commit to a specific usage, so basically compute savings plan or savings plan come with a duration of 1 to 3 years. So you can unlock like significant discounts on your compute cost, including Lambda cost. So they are beneficial like when you commit to a consistent usage level. AWS is basically rewarding you with a discount on your Lambda usage. So depending on what plan you choose, you could save up to 66% compared to an on demand pricing. So leveraging like compute plans is also a very good strategy to reduce your Lambda cost. And then uh, like leveraging compute plans is also giving you flexibility and predictable budgeting, and it is also best for consistent usage. So basically like if you leverage a compute savings plan, it's a smarter way to save money and have a steady usage over a longer period. Next strategy that we would see is implementing batch processing. So what is batch processing? So batch processing in AWS, like it leads to processing multiple records in a single function execution to lower invocation cost. So when it comes to Lambda, so batch processing in Lambda refers to processing multiple records or items in a single execution of a Lambda function rather than invoking the function separately for each record. So with the help of batch processing, you are lowering your invocation cost, as Lambda pricing is based on the number of invocations and the duration of function execution. So basically when you implement batch processing, you can, instead of like invoking multiple Lambda functions, you can process them into a single invocation, and this is helping you again to improve efficiency, save time, and like again reduce cost. So if you see a real world example and see where implementing batch processing helps, so for example, when you process messages from an SQS queue or items in a DynamoDB table, you can batch them into multiple messages or items in one Lambda invocation rather than, triggering the functions for multiple individual messages. So this is an example case scenario where you can implement batch processing. And this is again, helping you to reduce your Lambda cost. So implementing batch processing is also one such strategy. And next is executing event filtering. So what is event filtering and how is it helping you to reduce cost? So event filtering allows you to control which event triggers your AWS Lambda functions based on specific conditions or criteria. So this is especially important when you're working with event-driven architectures like involving S3, DNS, or SQS. And by filtering events before invoking your Lambda functions, you can, uh, reduce your unnecessary invocations. You can set filters to ensure that your Lambda function only runs when a specific event or condition is met. So, like if you consider an example, like suppose if you're processing an S3 file uploads, you might want to filter out certain types or only trigger the function for certain prefixes or pattern in the file names. So this is also an important strategy to help you reduce your Lambda cost. Yeah. So I guess that's it today from my side. So I have basically, walked you through the art of writing no-cost code in AWS, introduction to serverless, and then again strategies to reduce your Lambda cost. So that's it from my side today, and I would also like to thank the organizers for, organizing this AWS Community Gathering, and also giving me a chance to present my opinions and share with all the fellow members in the community. So thank you. That's it from my side.
Thank you. Thank you so much for the wonderful talk. And I'm sure your inspiring career has given a lot of courage to many women. The free tier is such a great way to explore, run, and plot type. And the right serverless uploads can really bring happiness and ease to so many people, and we are living in an amazing time for that. Thank you so much. And now, does anyone have any questions or comments for Sanika? Do you have? No more question? Okay, thank you,
No.
Sanika.
Welcome.
So, thank you. So, I will closing talk. Okay, Yuki-san, okay?
Okay. Closing,
Okay,
please. Okay.
Okay, so to all of today's speakers, thank you so much for your incredible talks. I thoroughly appreciate everything you shared. The insights shared by all of the speakers were not only powerful, but also practical and relatable. So each talk offered helpful hints for challenges that many of us face in different ways. Thank you for such a meaningful and inspiring time. And one last thing, please feel free to drop your social media handles in the chat and connect with each other. I really hope we can all stay in touch. To be honest, I don't know if what we are doing here is exactly right or not, but I do know that we want more voices like all of yours to be heard around the world. And so I'll keep doing my best to grow this community with all of you. Uh, I'm already looking forward to the next time we meet. See you again soon. Thank you so much.
Live streaming. Stop.
Bye bye.
Bye.